In this section, we've added a whole new class of functions to our library of functions that we can transform, reflect, shift, compress, and stretch. So the parent exponential function is f of x equals just plane a to plane x. So just a constant a, the base, to just a plane x. Nothing being added, subtracted to that x, just a plane base and a plane x. The shape of this graph depends on the value of a, the value of that base. Remember that base is the growth factor. So if a is greater than 1, it's going to be an increasing shape like this. I call this a ramp. Some of my students have called this a ramp or a swoop. So let's look at an example with a specific function here. So if a is greater than 1, an example of that would be y equals 3 to the x. So if we make a table of values here, an xy table, we know that easy points, key points that are convenient when we're sketching graphs, 0, 1, and negative 1. So it turns out those do work here. So we'll do negative 1, 0, and 1. So when you guys do transformations of these, you want to use these 3 key points. So if I plug in a negative 1 for x into this function, 3 to the negative 1, remember negative 1 means reciprocal, so the reciprocal of 3 is 1/3. And then if I take 3 to the 0 power, I'm going to get 1. Anything to the 0 power is 1. And if I take 3 to the first power, I'm going to get 3. So if you look over on this general example here with the a, generic a written in there, we can add, so we've got negative 1, 1/3. You may just want to sketch this on here because sometimes it's easier with a number than that a. Here's your 0, 1, and then here's our 1, 3. So those are our key points. So generally, our key points, negative 1, so if we go into our general function here, negative 1, a to the negative 1 power is going to be the reciprocal of a, 1 over a. And if we put in a 0 into the general function, a to the 0, anything to the 0 is 1. And then if we plug in a negative 1 for our x value, or sorry, a positive 1 into our x value, a to the first power is a. So we'll have 1a. So these key points just depend on that value of a, but these are going to be consistent for all of these exponential functions. And then if we look at the domain of this function, we can see it's negative infinity to infinity. But our range, this function is actually bounded by the x-axis, or the line y equals 0. This is actually a horizontal asymptote. And if you think about it, no matter what value of x we plug in here into this function, we're never going to get out a negative y value. Because even if we raise a to a negative exponent, like negative 1, we still get a positive number, a fraction. So these functions have a range from 0 to infinity, and that horizontal asymptote is at y equals 0. And we can see then, because of that asymptote, there's no x-intercepts, and we can see the y-intercept is 0, 1. So when a is greater than 1, we've got this ramp swoop shape, and it's increasing. This is an increasing ramp shape. And that makes sense because if our growth factor, a is our growth factor, if it's greater than 1, that means it's actually increasing. And you might want to make a little note here. This is your a is your growth factor. Okay, if we scroll down here a little bit, now we look at when a is between 0 and 1. So like a fraction or a decimal between 0 and 1. So for example, we could have y equals 1/2 to the x power. So if I make a table of values here with this, again, those easy points, those key easy points work on this function, negative 1, 0, and 1. So if I put in a negative 1 for x into my function here, 1/2 to the negative 1 power, that's the reciprocal of 1/2, which will give us 2. And if I put a 0 in for x here, anything to the 0 power will give us 1. And if I put a 1 in for the x here, we'll get 1/2. So if we go over on this general example here, here's negative 1, 1 over a. Well, our 1 over a is actually 2. So this is negative 1, 2. Here's the 0, 1 that we got. And here's the 1a. Well, our a is 1/2, so this is our 1/2. And again, we still have that same ramp shape, except now it's a decreasing ramp shape because that growth factor was between 0 and 1. It's actually, quote unquote, growing by a factor of 1/2, which means it's actually decreasing. So this is a decreasing ramp shape because that growth factor is between 0 and 1. So all of this information at the top, the key points, the domain, range, the shape, the asymptote, the intercepts, it's exactly the same whether a is greater than 1 or between 0 and 1. The only difference is if a is greater than 1, it's going to be an increasing shape. If a is between 0 and 1, it's a decreasing shape. So you guys will do transformations with these and you'll use these key points.